Well, you want to be in second place too?
That'll lose him half a point.
We're gonna deduct a point just for that question. Okay. All right, isolate, number 3, isolate the system from the nitrogen source. Okay, tap the gauge lightly to make sure that the needle is free and record the pressure. If the pressure falls over time, the system has a leak. Is that true or false?
Could be false.
Why?
The gauges could be faulty.
Okay, why else?
Not have your gauge screwed on all the way.
Okay, next.
Didn't we put refrigerant in it?
Yes,
Okay. Changing temperature?
yes. All 3 are great, great answers, but you get no points.
No.
Now, if one of you'd come up with all 3 answers, I'd give you a point. Okay. Any drop in the pressure after compensating for the temperature change indicates a leak. Wow! In the next sentence, it gives that particular information. If you see a pressure drop, remember it could be the manifold gauge and connections are leaking, not the system. Didn't we just talk about that, right? Okay. Check for leaks while the system is pressurized because the leak is easier to detect. Okay. If refrigerant was added in step 1 before the system was pressurized, you can use an electronic leak detector. Otherwise, use soap bubbles or ultrasonic leak detector. Now, the new leak detectors, electronic leak detectors, detect what?
Oxygen.
Lack thereof. Okay? You can literally take if you could pull a vacuum and stick electronic leak detector, the new ones, and you put it in that vacuum chamber, it's gonna go nuts because there's no oxygen to detect, okay? When you're convinced that the system is leak-free, dehydrate the system using the triple evacuation method to ensure that no trapped air, refrigerant, water is in the system. Evacuate to at least 500 microns. Okay, one person. What is the triple evacuation method?
Nitrogen.
Pull a vacuum, hit it with nitrogen, pull a vacuum, hit it with nitrogen, pull a vacuum, hit it with nitrogen.
Okay, so both of you agree?
We pull back in 1500 a couple times and then 500.
Okay. What happens if it goes below 500?
That's good.
It's just a better vacuum.
Okay. But it has to be at least a minimum of 500.
Right.
Okay. This is a 10-point bonus question.
Uh-oh.
10 points. What is the time that it has to maintain once the gauges are off at that 500 microns?
15, 20 minutes.
30.
45.
An hour?
Depends on how big the system is.
Okay, according to the book, it's 15 to 20 minutes. According to the EPA section 608, it's 5 minutes. Okay, so I will assuredly tell you that in a course of about 15 to 20 minutes, you are going to see your micron meter go up from the 500 microns. I actually tried it, and I broke out a brand new set of gauges, just like the ones that you're going to receive, that you're using in class, the JBs, made sure everything was seated correctly. I could not get it to hold for 15 minutes. I could get it to hold for about 7.5. Was about as close as I could get. 5 minutes is a good test, and there is in the book, there is an acceptable amount. It can't raise more than, like, I think 10 microns in that 5-minute period. Okay, but thing to remember that, like a golf game, the lower your micron reading, the better vacuum you have, the better chance that you have no humidity, no non-condensables, no non-compressed, you have no junk in your system, period. Because otherwise, it can't happen, all right? You can literally have water trapped underneath oil and pull 500 microns. And then all of a sudden, it starts to bubble. And then the next thing you know, you're above 500 microns. And you may have been there for 2 or 3 minutes. That's why they want you to test it for a minimum of 5 minutes, okay? Yeah. So, to determine the maximum allowable pressure to use when leak checking system, check the design pressure on the equipment and nameplate. And James and Lucas both, you're getting both 10 points. Actually, I'm gonna split it 5 apiece because you were cohabitors in that answer. 1, 2, 3, 4, 5. 2, 3, 4, 5. Tommy, you're falling behind. To determine the maximum allowable pressure, use a leak test, leak checking when the system check design pressure. What is that unit that we talked about? What's the design pressure? Luke. This one right back here that we were talking about earlier. What's that design pressure?
250.
250. We get a bonus point for Luke. Jim, we're going to get you another question. We're going to get you up there with them. All right? If no nameplate exists, use the normal operating condenser temperature and the saturated pressure temperature table of the refrigerant to determine the normal operating condensing pressure. Use that pressure. Jim, that one's for you. We're at R22. I mean, let's not even do R22. Let's do 410A, okay? Because that's the most you're gonna be using more 410A, okay? You got 410A, all right? It's 80 degrees outside. What's our answer?
235?
Okay, 235. Is that right, guys? All right. So you're going to pressurize the system to what, Jim?
Did he say condenser?
At 80 degrees?
80 degrees.
235?
235. 235 psi. Jim got another point. Good job, buddy.
Did he say condenser?
What?
Nothing?
He didn't hear you, and I was thinking,
Oh.
I was doing something else.
But
No.
don't we take the 30,
That's what I was gonna ask, but I
Yeah.
wasn't sure if he said condenser or.
that's what I was asking.
Okay. What it says here is if for some reason that plate, that nomenclature plate back there, the information, the data plate is gone. And what you're going to find out is when you get out in the field, expect for them all to be gone. For some reason, Goodman has been the best at having, they did a fabulous job of making sure that the data plates are there, okay? Don't know how, but they did. Everybody else really pretty much stinks. It's all the way, they fade, they're gone, someone's rubbed them and made it worse. Some of them are made of metal and people have painted over them and you just can't see them, okay? So when you have no other choice, then you take, it's an R22 system or 410A system, you say, okay, temperature outside is 80 degrees, standing pressure, 235 psi, that is what I'm going to pressurize the system at. That's my standing pressure or idle pressure or static pressure, okay? Static meaning not running. Low pressure systems typically have a pressure relief valve set at 15 psi. Therefore, are unusually in field pressure tested to are usually tested to 10 psi. So because they have the pressure relief valve, they can be running anywhere from less than 15 psi. So you don't want to don't want to put too much pressure in it. Refrigeration systems are designed to run only with refrigerant and oil circulating through them. Except for low pressure systems, most systems have normal operating pressures that are above atmospheric pressure. Even if the system has a leak, air and non-condensables can't normally enter the system unless essentially all the charge has leaked out or the charge is low enough so that the compressor is drawing the low side pressure below the ambient pressure. Therefore, dehydration of the system is only required if the system is open up, allowing air to enter the system. A deep vacuum to 500 microns is necessary to dehydrate the system. Okay, let's break this one down, all right? Does everybody see these? Anybody want to write them down? Okay. Was that a yes? You want to take a picture of them? Got it?
Yep, I got it.
Okay. All right. What happens is we have a situation where we come up to a unit that is not running, all right? And the homeowner says, you know, it just doesn't cool my house. I don't know why, it just doesn't. So you go, okay, so you go put gauges on it. And remember what I said, 2 ounces of R22 equals to what pressure, PSI, in a line set that's 15 feet or less?
120.
120 PSI, absolutely. So, we know that that's 2 ounces, right? So 2 ounces equals 120 PSI. Well, when that compressor kicks on, you've got a gauge that's sitting up here at the needles at 120. Here's 0. And according to what we just read, it says, where is that word? Above atmospheric pressure. At or above atmospheric pressure. On a gauge, what is atmospheric pressure? What's that read?
0.
Absolutely 0, okay? So, all of a sudden, we have here at 120, that's where it's sitting idle or static, and the next thing you know, we're sitting down here in the negatives. What's happening, guys?
Going into a vacuum.
It's going into a vacuum. The compressor is pulling what in?
All that gunk and
Right.
There's moisture.
Yep. So now then, what you just did was you turn around and you go, oh, this is wrong. And you pull the disconnect out of the wall, you shut it off, and you wait a few minutes, and now it's back up to 120. You go, wait a second here. I got 120 PSI again. So what are you going to do?
Charge the system.
Pardon?
Charge the system.
Charge the system. Why don't we look for a leak?
I'd probably,
The reason I'm saying that is because if it's operating, there's only one good reason that this is doing this, okay? If you have a full charge in the system, you have a restriction somewhere else that's causing it to come down. Otherwise, you need to start looking for a leak in the system. And that is another detail for another class. Okay, I'm not going to get into that tonight. So, you've got 120 PSI at standing. When the system runs, it goes down to a -5 or below or even just below atmospheric pressure, then you know almost without a doubt that you have an issue with a leak, okay? That's the first thing you need to start with. Now, there may be other issues that you will find, but that's one of the first things you're gonna look for, is a leak, okay? And that's what it says here. Or it says here halfway through, air and non-condensables can't normally enter the system unless essentially all the charge has leaked out or the charge is low enough. And I would advise you to all highlight that, underline it, star it, something, because you will go back to that at some point in time, okay? The charge is low enough that the compressor is drawing the low side pressure below the ambient pressure, okay? So therefore, the system is only required if the system was open, a dehydration of the system, if it was opened. That's if you've got pressure, okay? If it was pressurized and you find the leak, then you don't have to worry so much, you know. But when you open it, or you have a situation like this where it goes below, you're pulling junk back in the system, okay? That's when you need to recover what Freon you can out of what's in there, and you pressurize with nitrogen and you go through the whole decay testing, okay? Removing trapped water with a deep evacuation. You can remove the water or trapped refrigerant by repeating the deep vacuum drawdown process until all the water or refrigerant has been boiled off the system, holds the deep vacuum, and the system holds the deep vacuum. Heating the system helps remove the trapped water by increasing the vapor pressure of the water and preventing the water from freezing. If the water freezes, evacuation is much slower. For this reason, if you use a vacuum pump that is too large, the vacuum in the system could drop too fast, potentially causing evaporating water to cool and freeze, making further water removal much more difficult. If the water doesn't freeze, the lower temperature of the water lowers the boiling point of the refrigerant, making a deeper vacuum necessary to evaporate the remaining, now cooler water. I went to a dealer meeting in Vegas some years ago, and a guy was trying to sell vacuum pumps. He had test tubes, and he had a little bit of water at the bottom of them. He'd put the cap on, he'd hook it to the pump, turn the pump on, and you'd sit there. And about 30 seconds later, it'd start to bubble. And about 30 seconds later, it'd start to royal bubble. Then all of a sudden, the test tube would frost up, and then everything was gone. Do it again. I sat and watched that process probably 8, 9, 10 times. And then I went back the next day and watched it again. And the reason I did, I was so infatuated by that one example, because it gave me the realization after doing some research that those evacuation pumps can put us in such a deep vacuum that water boils at a negative 40 degrees. Okay? What does water do at a negative 40 degrees? Freezes solid, doesn't it? What does water boil? 212. Okay? 212 degrees. Now, unless you're in Colorado. If you're in Colorado, water will not boil at 212 degrees. Because the atmospheric pressure is
Lower.
That's right, it's lower. So it has to be upwards of 225 to 230 for water to boil. If you don't believe me, call any of your friends that live in Colorado and ask them how tough their spaghetti is at 212 degrees. So, you know, these are just some of the things that we get to do scientific experiments every day out in the field, and it's a blast. All right? So when you put an evacuation pump on, and you're gonna see that a compressor, if you have a point where, especially if it's cold outside, guys, we're getting ready to go in the winter, right? So in the wintertime, I've been out there and I've literally had to put a pump on, and it's -5, it's -10. Last year was -9, and I'm out there. Try welding line when it's -9. Okay, you have to make sure that you preheat the copper, because you put the flame on there too fast, I've actually seen it crack. Okay, then what do you have? Leak. Okay, so one thing that'll help you is that when you get everything, and no one complain about my artistry, I'm docking all the points. When you get a compressor and you've got it all done up, and it kind of looks like an Ewok, so you've got refrigerant oil right here, okay? And around the bottom, there's a thing called a crankcase heater, and it goes over to your high voltage electrical. It's 240 volts. What you want to do is when you are leak testing, you want to make sure that there's no low voltage going to your system, because you don't want the system to come on. That's bad, okay? But you do want to make sure that crankcase heater is working, because that's going to help warm up this oil, which warming up the oil helps warm up any water that may be in the system, which eventually, because of your evacuation, is going to help you evacuate the system faster, okay? Because doesn't it say right here, heating a system helps to remove the trapped water by increasing the vapor pressure, right? It works. Now what you don't want to do, I've seen it done, I don't advocate it. Do not take a torch and try to heat up the compressor with a torch. No, no. Absolute no, no. Okay? Triple evacuation method. A triple evacuation is an evacuation method where the system is initially evacuated to the deepest vacuum possible, usually at least 2,000 microns. Then a small amount of dry nitrogen is introduced into the system to raise the pressure to above ambient pressure. What's ambient pressure again?
14.7.
The outside
Oh, the
temperature.
outside temperature.
Ambient pressure,
Oh, 0?
0. Okay? That's basically, that's your, yeah, it's just 0. So that's where your gauges sit and rest, okay? So it's not in a, it's not in a vacuum, okay? So you want to raise it to about 10 or 15 psi. And all you're doing there is you're not looking to leak test the system again. You're just looking to that dry nitrogen to gather up some of the moisture that happens to be in your system, okay? A paper towel is dry, right? You put it on a wet spot, it soaks up the moisture. Okay, nitrogen is kind of like a paper towel. It's dry nitrogen, soaks up the moisture. So then, once you do that, then you purge it out of your system until it gets to just above your ambient pressure, okay? Because it says nitrogen is purged or vented typically through the vacuum pump. This system, then the system is evacuated again. Recovery of the nitrogen isn't required. This process of evacuation followed by nitrogen pressurization is repeated. Now, I don't like nitrogen going through my pump. That's me personally. You have to determine that with whoever you go to work for, okay? That's just my personal opinion. Typically at least 3 total evacuations, and the final evacuation should be achieved at a vacuum of at least what?
500 microns.
500 microns, exactly. Triple evacuation is an effective method for dehydration because it uses the, what kind of nitrogen? Sweep through the refrigerant lines and push out any residual what?
Moisture.
Absolutely. Air is 78% nitrogen, so this process does not harm the environment. During each vacuum decay test, isolate the system from the vacuum pump and wait to see if the pressure rises. What does it mean by isolate the system from the vacuum pump?
Shut it off completely, so no gas can get through, or
But what are you shutting off?
The vacuum pump.
gauges.
Okay, we got gauge and we have vacuum pump. Anybody else? How about both? Can you do both? Okay, here's something I'm gonna tell you. If you have, now, once again, understand, guys, this is me personally, okay? When I have a situation like that, what I normally do, and what the guys who worked for me did, when we pressurized to 10 or 15 PSI, once we get that point, we turn the gauge off, okay? Once we turn the gauge off, then we disconnect the hose from the pump. And this nice little valve here, ball valve, we turn it off. We then open it up, just barely open up that valve, and we watch until it gets to just below 5 PSI. Between the 5 and the 0. I turn it off, I still have pressure. Okay? This hose has now been exposed to what?
The air, ambient air.
Ambient air. Okay? I put it back on the pump, I turn the pump back on, and I wait about a minute to a minute and a half so it can evacuate that out of there, okay? And get it going back into a mercury or micron setting. Then I open this back up and it sucks the rest of the 2 or 3 PSI of nitrogen out of my system, okay? That's me personally, because I don't like a lot of nitrogen going through my pump. Every employer has their own way, okay? You need to follow their example. The worst thing you can do is, well, that's not the way we did it in school, okay? So if they tell you to do it one way, that's the way they want it, that's what you really need to do, okay? All right. We got there. If you see an increase in pressure, the system could have a leak, but this is doubtful because you've already passed the pressure decay test in the system at a much higher pressure. If the pressure increases to a point and then it stops at some point either above or below the 0 PSIG, this indicates that water, if below 0 PSI, or refrigerant, if above, is still evaporating. Only if the system had a leak would the pressure increase and stop at 0. Y'all understand what that means?
You just explained that a minute ago, didn't you?
Basically what it is, if you have water droplets sitting in here in this oil, then according to this, it's going to come just below the 0 PSI. Okay? Because you still have water boiling off. You can't maintain your microns. Okay? But if for some reason that's gone and it goes above that 0 PSI, now then you've got refrigerant that has not evaporated out of your oil yet. It's still trapped in the oil, okay? if all of a sudden it reaches 0 and it doesn't stop below and doesn't go above, that means you've got a leak somewhere. You need to pressurize and start over. Now, the thing that I would do is, first thing I'm gonna check is if I was pulling down and I was holding before and I wasn't going above that 0, I'd be checking my gauges, making sure that my seals are good and everything else. And if everything's good, unfortunately guys, start over. Okay? It can, sometimes it shouldn't, but sometimes it's better to start over and start that triple process again than it is to go, oh, it's fine. I'm about, we're having dinner in an hour. I got to hurry up and get out of here. Well, remember, you wouldn't want that mechanic to do the same thing with your car. Okay? So, okay. If the pressure reaches above 0, refrigerant is still trapped in the system. Now, what we just talked about? The refrigerant could be trapped in or under any oil in the system. The trapped refrigerant is continuing to evaporate, which is causing the vapor pressure to rise above the ambient pressure. I've seen this happen, especially in the wintertime. It's harder for it to leave because the pressures are low. Look at your temperature charts. If you're sitting at 9 degrees, 0 degrees outside, I've actually seen my boss take R22 at about 4 degrees outside and crack open the gauges just a little bit and watch water drip into a styrofoam, watch the Freon drip into a styrofoam cup. Okay? It's so cold that it will drip liquid. Now it won't stay because it's still warmer than its boiling point. Okay? But it takes longer for that to boil off. So there are some occasions that you're just gonna have to leave. Pressurize it with dry nitrogen. Make sure the crankcase heater is on. Go home, come back tomorrow. Okay? It does happen. Not often, but you'll find out it does happen. It's okay. If the Freon continues to evaporate, which causes the vapor to rise above ambient pressure. If the pressure rises from the initial deep vacuum, but stops at some vacuum level below ambient pressure, water is probably trapped in the system. That's going to be the same problem. Now, what I'll do is, if I see that happening, a lot of times, if I know that it's water and it's not refrigerant, I'll leave my pump on overnight. Pump's running. It can only go in a deeper vacuum. Got to make sure you keep the oil clean. It's not going to hurt anything. I actually put a system in for my parents, and I was going to stick the vacuum pump on just to make sure, because it was the outdoor unit came in with no charge in it, and I wanted to make sure there was no leaks. I accidentally left the pump on for 2 weeks. Well, it was going to go into a vacuum anyway. So, if any water was in the system, it was gone by the time I got back to it. I had stuff to do. Okay? So, as long as your pump's in good shape and it's a good working pump, they're designed to run. It's not going to hurt anything. Okay? Any questions? All right. Whenever you use dry nitrogen from a portable cylinder, you must use a pressure regulator for safety reasons. What's the pressure in the portable cylinder? About
2400.
About 2400. You should always use a pressure relief valve or burst disc. Insert downstream from the pressure regulator to avoid overpressuring the system. Basically, it's the pressure regulator, okay? It's got the burst valve in it. Required tools. You need to perform a triple evacuation or a 2-stage pump, nitrogen, with a regulator and a micron gauge, micron vacuum and gauge. Okay, and a set of gauges. The vacuum pump removes fluids such as air, other non-condensable gases, water from the system, drawing the system pressure to below atmospheric pressure. A vacuum pump can consist of a single or two-stage design, but a two-stage vacuum pump is necessary for HVACR work. Rich, what's your intake on that?
Always hit by if you're gonna spend money on a vacuum pump, buy a good one to begin with. 2-stage with a ballast, at least a 5 CFM, if not more.
I don't disagree.
And you're talking only about $40 more for a good pump versus what you're gonna get otherwise.
Buy a good pump, change the oil often.
Yep.
You don't have to change it after every change out, but if you have a burnout, you absolutely change it out of burnout, and you'll learn more about those later in the semester. I always change my oil after every second installation or second hard, deep evacuation. Okay? Oil's cheap. When you consider those vacuum pumps, if you can buy a good used one, you're gonna spend a couple of hundred. New, you're gonna spend $385 to $600. So $10 in oil is pretty cheap to make sure you're not out of business. Okay? A vacuum pump removes, okay, we just read that. A vacuum pump can also have a gas valve, which helps prevent moisture that is being removed from the system from condensing into the pump and reducing vacuum availability from vacuum level. Anytime a two-stage pump can't easily achieve a deep vacuum of at least 500 microns when isolated, the vacuum oil could be contaminated with water and the oil needs to be changed. If you change it every second time, do you think it's going to be contaminated much? Probably not.
So we got 2 pumps here.
Yes. In fact,
The one's a 6-stage with a ballast,
two-stage
or
ballast.
2-stage with ballast, 6 CFM. The other one's smaller, 5 CFM. I take that back. The smaller one's actually a 6 CFM, if I'm right. The smaller one's a 6 CFM, am I right?
Yep, that's 6.
Okay. But the nice thing about it, it's 2 volt, it's dual voltage, 110 or 220,
Right.
and it's lightweight. Still gotta change the oil the same, but it's a single stage. The other one, which you'll know it's 2-stage because it's much heavier, 5 CFM, the cost difference is about $80. The bigger the system, you want the 2-stage. The smaller systems, the single stage is fine, just because, it's kind of where you're going. Sometimes that lightweight really is handy.
Okay. Now then, I'm going to kind of be. Now this comes down to preference, and I'm kind of going to disagree with Rich a little bit here. Okay. I've had 2 stages when that's what I was told had to be. Okay. I ended up going to a single stage, but dual voltage. I found out that the dual voltage acts a whole lot like the 2-stage. Whereas if I'm running it in 220, it pumps down faster and deeper. If I'm running it in 110, it takes longer, doesn't work as fast, but still works adequately. Okay, I can still get the same drawdown, but not quite as fast. The other thing I like about it, how many people have seen this cord?
They're on TVs everywhere.
Everywhere. This one, you mess that cord up, guess what? You gotta unwire it and rewire it, and when you're out in the field, I always carry a spare. Okay? So if it gets cut for whatever, stomped, rolled over, mutilated, I've always got a spare because they're on TVs everywhere. Okay? Now that's just my personal opinion. Okay? You have to decide what's going to be best for y'all. two-stage pumps are great. There's no doubt about it. It's kind of like, anybody ride motorcycles? Okay. Even in cars, when you're getting into that spot that you're going up a big hill, a load, you gear down. And that's a lot what the two-stage pump does. It basically gears down and it just gets really moving and just pumping that hard to pump all that oxygen out, that air, get the humidity down, okay? So, how often, it says, how often should you change the oil according to this?
Every time, don't they?
Nope. I think it says if you can't at least pull down 500 microns into your gauges. Okay? So basically what that means is, once in a while, it would probably behoove you to take your micron gauge and hook it up to your gauges and hook it up to your pump and just see what it does. Because if you're consistently, if you change the oil in it and you're only pulling 700-800 microns, you need a new pump, or you need a new set of gauges. Okay? Don't wait, change the oil in them until the supply houses does it for free. They do it twice a year for free. Don't wait that long. Okay? That's just a ploy to get you in to buy their pump. All right? If you've got a good pump and you take care of it, I've had mine for 20 plus years, and I'm still using the same pump that I started with. I have others that I thought might be better, but I still have my original pump. All right. Which 14, figure 14, which is on the back side, shows a two-stage vacuum pump and the location of the gas ballast valve. Who needs points? Wow. Luke, Jim, and Shane. Okay, we're gonna give Jim a chance since he's stuck over here in the corner. Jim, where's the ballast valve out on this?
Is it on the top there?
This here?
Yeah.
Try again.
On the back?
Here?
No.
Here? Here?
No.
How about if I bring it in here and you look at it and you tell me?
Would that be it?
No. We're gonna give someone else a shot. Okay, Luke, you're next in line. Show me the gas ballast valve. Absolutely. What does it do? Now that you know where it's at.
It's for adjusting the pressure of the gas.
It equalizes the pressure in there. So when you hook your gauges up, you start this up and you open it up, all it does is just it gives equalization of pressure. Okay? You shut it back off, and if for any reason, sometimes some pumps, I have one that does this, it will actually push oil. If you leave it open too long, it'll push oil out this back vent handle. Okay? That's nice that they put the plugs in them now.
And if you leave it in, it pops out,
Yeah.
so you're good. Scare the hell out of you sometimes.
Right. The gas ballast valve is used to help keep impurities such as refrigerants and moisture from condensing and mixing with the vacuum pump oil. If refrigerant or moisture condenses in the vacuum pump oil, the vacuum pump won't be able to obtain a deep vacuum. During the first stages of evacuation, Refrigerant or moisture vapors are more highly concentrated. As for finding it. Okay, the gas ballast valve also allows some ambient air to come into the vacuum pump to dilute the impurities and reduce the condensation or the condensing of refrigerant moisture into the vacuum pump. Okay, procedure for using the gas ballast valve: keep the ballast gas valve closed when the vacuum pump isn't being used. After connecting the vacuum pump and starting evacuation, open the gas ballast valve a quarter to full open during the initial evacuation. That's not for long periods. That's only for a moment. Okay? So open it up. It's just a pressure relief valve. Close it back off. All right? When the vacuum pressure drops to the vacuum of at least 20 to 25 inches of mercury, which will be really quick most of the time, close the gas ballast valve and continue the evacuation process to reach the ultimate vacuum. If you forget to close the valve, a deep vacuum won't be achieved. So you just can't leave it open. Any questions on that? Okay, vacuum pumps are rated for a degree of vacuum they can achieve in microns. Two-stage vacuum pump is necessary to pull the deep vacuum, which is necessary for proper deep evacuation and removal of water in the system. So what's a deep vacuum again?
Below 500.
Below 500. The extraction of air and non-condensables lowers the pressure inside the system below atmospheric pressure, which causes any trapped liquid water to evaporate and be exhausted by the vacuum pump. So basically, it's sucking air out of the line set, right? Okay, it's not only sucking air out, but what else is it doing?
The moisture,
Moisture, absolutely. Anything else?
contaminants,
Contaminants like?
like sludge or things that get,
Sludge, it doesn't, I mean, if sludge is there, sludge is there. Okay, we can't do anything about sludge. It's just one of those things. Go ahead.
Oil.
Oil? Nope, it's not gonna remove oil. Oil's there, it's oil's there.
dust.
Nope.
Oxygen.
Air, non-condensables. What happens if the stuff gets stuck here? Refrigerant, absolutely. It helps get the refrigerant out of the line also, okay? The extraction of air and non-condensable lowers the pressure inside the system below atmospheric pressure, which causes any trapped water to evaporate and be exhausted by the vacuum pump. An electronic vacuum gauge or micron gauge displays the vacuum level directly in microns. This is the only accurate field method to determine the evacuation level of a deep vacuum. Now, last class I asked if anybody had an electronic set of gauges that had a micron gauge on it. And a student said yes. Come to find out, he said it tells you in the book, in the manufacturer's book, don't use it as a reference to degrees of micron. It's only there because it's part of the kit, okay? So get yourself, if you don't have one, get yourself a good micron gauge, okay? And make sure that when you put it on, that most of your micron gauges, if you get it too low, oil will get in them. If oil gets in them, you might as well just throw it away, go buy another one. I've never been able to fix one that oil got into. Okay, have you?
Nope, they're done.
Yeah. And you're gonna spend at least $100 on a halfway decent one. And it's $100 you just don't wanna blow every couple of weeks because you got it too low, okay? An electronic, deep vacuum. C15 shows a typical electronic micron gauge. The micron gauge is far more accurate than measuring deep vacuum. What is absolute vacuum? what micron, inches of mercury?
30.
Absolutely, absolutely. That was a good one. James? Okay, somebody else other than James. Let's try Shane. Shane, what is the normal vacuum, inches of vacuum that our gauges, that just pulls, because we can't get 30 out of it?
Usually between 5 and 10. Is
Nope.
there 15?
I'll give you a hint, it's 20 something point something 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 into infinity. It's never 30. Because we cannot achieve 30. Jim?
I was gonna guess 29.999.
Absolutely. Absolutely. 29.99999 to infinity. Because the only thing that has absolute perfect vacuum is a what?
Black hole.
Black hole. Okay, off the wall question. Why do they call planets planets? Watch The Big Bang Theory and you'll find out.
God, I've already watched that.
It's in one episode. Okay, that was just because mention of black hole. They do reference planets in one episode. It was kind of funny. Okay, we all know what a micron gauge looks like, right? Okay. The blue low pressure side gauge on the manifold set measures evacuation levels by using an inaccurate scale based on the inches of what?
Mercury.
This scale ranges from 0 inches, no vacuum, to 30 inches, full vacuum. By comparison, the micron gauge expands this scale to a deeper vacuum levels, providing greater measurement resolution. Basically, it's saying that as good as gauges are, when it comes to a negative pressure, it can't compare to a micron gauge, okay? Evacuation process. When you evacuate a system, you need accurate readings from the micron gauge. For the most accurate readings, connect your vacuum gauge close to the system to be evacuated, and as far as possible away from the vacuum pump. Never connect the gauge in line between the vacuum pump and the system. Always measure the vacuum with the vacuum pump shut off and isolated. Okay, why don't we take 5 minutes and we'll go through that paragraph again, and then we'll figure out what to do, okay? We got a couple more things to look at, and then we'll go in and we'll start messing around with some of this stuff. Come back with questions.